Hi, hello students, welcome to Software Future Academy SAT oriented session. See, in this session I will explain some questions which is related to your ZAT examination topic. Okay, see, our ZAT examination is coming, its date is October 2nd 2023. So I think you all of them are very well preparing for that examination. See, in this session I discuss the topic light. What is light? Light means it is a form of energy. We all of them have enough idea related to light. See, there are two important phenomena related to light. One is reflection and refraction. Mainly in this chapter we will discuss these two important phenomena. One is reflection and another one is refraction. Okay, so all the questions which is related to these two important topics, reflection and refraction. Okay, so our first first question, that is, see, this one is the first question. See, the question is: a plane mirror is moved towards a stationary observer with a uniform speed of 2 meters per second. The speed with which the image will move towards observer will be. That is the question. See, here the observer is stationary. See, stationary observer. Okay, so you just consider he is the observer, he is stationary, that means he is standing in a particular position. You just consider this one is the plane mirror. Okay, so when the plane mirror is moving towards the observer with a velocity v, here we know the velocity, it is equal to 2 meters per second. Okay, so here this one is 2 meters per second. See, his image is formed at a distance. You just consider both observer and mirror are in the stationary state, then the distance between the observer and the distance between the mirror and image, that one is d. Okay, when the mirror moving towards the observer, at that time the image will move towards the observer, right, with the same speed 2 meters per second, with the same speed 2 meters per second. Okay, so now the net velocity of the image moving towards the observer, that is 2 meters per second plus 2 meters per second. Okay, that means the equation is 2v. Okay, so its answer is 4 meters per second. Clear? 4 meters per second. So 4 meters per second is also written in the form 4 meters second raised to minus 1. So here the option 4 is the right answer. Okay, see, actually this one is this question is coming from the part reflection. Okay, see, mainly reflection related to two types of mirrors. One is plane mirror and another one is spherical mirror. Okay, see, plane mirror means a straight mirror with one smooth straight surface with one smooth side. Okay, see, this one is a plane mirror. Okay, see, spherical mirror means it is a part of a sphere. Okay, there are two types of mirror. One is concave mirror, actually its smooth surface is curved inward, and this one is a convex mirror, its smooth surface is curved outward. Okay, so these are the two different types of mirrors. The first one is the plane mirror and the second one, that is the spherical mirror. Spherical mirrors are two types, one is concave mirror and another one is convex mirror. Okay, so all the reflection rules are same in the case of plane mirror and the spherical mirror. Okay, then if an incident ray passes through the center of curvature of a spherical mirror, the reflected ray will, see, actually this one is related to the law of reflection. Okay, law of reflection. See, here the question is an incident ray passes through the center of curvature. Okay, so you just consider a spherical mirror is present here. Okay, and this one is the pole of the spherical mirror. That means it is the center point of this mirror, and its focus is present here. its center of curvature, that one is present here. Okay, see the line which is passing through the center of curvature and pole of the mirror, that one is known as principal axis. Okay, that one is known as principal axis. See, when I place an object in front of the mirror, okay, then this one is a light ray which is coming from the top part of the object. It is parallel to the principal axis. See, the light ray which is parallel to the principal axis, after reflection, that light ray should passes through the principal focus. Okay, so this one is one of the law of reflection. And another law, that is, when the light ray passing through the principal focus, after reflection, that light ray should passing parallel to the principal axis. Okay, so this one is the second law of reflection. And the third one, that is, when the light ray passing through the center of curvature, when a light ray passing through the center of curvature, okay, so you just consider again the same mirror. This one is the principal axis. You just consider this one is the center of curvature. Okay, see, this one is the object. When a light ray passing through the center of curvature, then it retrace the same path. Okay, retrace the path. Retrace the path means it passing through the same line. Okay, passing through the same line in the opposite direction. Okay, so here the right answer, that is retrace its path. Option 3 is the right answer. Okay, that means this question is related to the law of reflection. So that part is a very important part related to the reflection of light. Okay, law of reflection. So some questions are surely some questions are taken from this part. Okay, question number 3. A ray of light traveling in a air falls obliquely on a surface of a calm pond. It will. Okay, so you see this one, this question is coming from the part refraction. Okay, what is refraction? Bending of light when it traveling from one medium to another medium, right? So here you just consider this one is the surface of the water, and the upper part of this line consists a particular medium, it is air, and lower this line or the in this region the medium is water. Okay, so when we compare the densities of these two media, here air is rarer than water. That means water is denser, air is rarer medium, right? So when a light ray entering to the surface interface of the two media, see, this one is the interface of two media. See, this one is the incident light ray. Actually it is it on the interface of the two media with a certain angle. Okay, so you just imagine a normal is present here. Okay, so now the light ray is coming from the rarer medium. So when it hits in this point, after hitting this point, the light ray passing through the water. Okay, so actually water is the denser medium. So the light ray moving to first, initially it bent and moving towards to the normal. Okay, clear? That means when light ray traveling from rarer medium to denser medium, after reflection the light ray move towards to the normal. Okay, when the light ray traveling from denser medium to rarer medium, at that moment after refraction the light ray move away from the normal, see here the median number 1 is air, median number 2 is water, here air is the rarer medium, water is the denser medium, therefore the light ray after refraction move towards to the normal. Okay, if the mediums are interchanged, that means when the water is present here, then air is present here, you just consider this one is the normal, this one is the light ray which is entering to the interface of the two media. After refraction, this light ray bending away from the normal. Why? Because here the rarer medium is present, here denser medium is present, light traveling from denser medium to rarer medium. Okay, so this is very important. So here the right answer, the light ray traveling from air to water, rarer to denser medium, therefore the light ray move towards to the normal. So light ray deviate towards to the normal, that is the right option. Option 3 is the right answer. Clear? Then question number 4. See what is the question number 4? An object is placed at f1 of a convex lens. The nature of the image found by it is. Okay, see here this one is again related to the topic refraction of spherical lenses. Okay, refraction by spherical lenses. See, actually convex lens and concave lens are the two different types of lens, different types of spherical lenses. Okay, so here the convex lens is like this and concave lens, that one is like this. Okay, see here the lens type, that is convex lens. Okay, the lens is a convex lens. So you just imagine this one is the convex lens. Okay, again I place the principal axis. See, this line is the principal axis which is passing through the center of curvature of the two sides of the lens and pole. Okay, then now the object is placed at f1. Okay, so this one is the position f1 and here this one is f2. Actually f means it is f is, see r is equal to 2f. See, this distance is known as focus. Okay, this distance is known as focal length. Okay, this distance is known as focal length. Okay, see again this distance is also equivalent to this one, and see C1 is the distance from the pole to center of curvature of the this side of the mirror. So here this one is radius of curvature. So radius of curvature is equal to 2 into focal length. Okay, so there is a relation present, radius of curvature is equal to 2 into focus, or focus is equal to radius of curvature divided by 2, radius of curvature divided by 2. Okay, then here our question is an object is placed at f1. Okay, so convex mirror, principal axis, f1, f2. Okay, then now the object is present here. The nature of the image found. See, first one light ray traveling through parallel to the principal axis. After refraction, that light ray should passing through the focus. Okay, then the another light ray which is passing through this way. Okay, so now the image is formed at infinity. Okay, image is formed at infinity. Actually the image formed at infinity, and the image is an inverted image. Okay, see, actually there is no space to draw the image. See, actually the image is formed at infinity and it is inverted image, and the size of the image, that is highly enlarged, okay, highly enlarged or magnified, okay. So here the right option, that is the image is real, yes, image is real, so all the option consist the same term, real. And the second one, the image is inverted, so there are three options consist the term inverted. And the last one, the image is highly magnified, so there are two options related to magnified, but one is highly magnified. So the more correct option, that is option 2, real, inverted and highly magnified, okay. Then again the next question, question number 5. Yes, again this one is related to the lens, okay, that means related to refraction, okay. See the question, that is two thin lenses of focal length plus 20 centimeter and plus 25 centimeter are placed in contact. The effective power of the combination is. So how we find out the power of the lens? See, power of the lens P is equal to 1 by focal length. The reciprocal of the focal length is known as power, right? So here there are two different lenses, thin lenses. Actually its focal lengths are different. The first lens, focal length of the first lens, that is f1, it is equal to plus 20 centimeter, and the second lens, its focal length f2 is equal to plus 25 centimeter. Clear? See, all these data are given in CGS system or centimeter system, right? So to find the power, we use P is equal to 1 by focal length. See, in here we use the focal length in meter, but right now the focal length is in centimeter, okay. So we use to find the power of the combination of two lenses, P is equal to P1 plus P2. See, this one is a very simple equation which is related to power. Actually power P is equal to 1 by F. So I rearrange or replace the equation like P is equal to 1 by F1 plus 1 by F2. 1 by F1 plus 1 by F2, okay. So now I again rearrange this equation by using the values. Now I use this 1 means 1 meter divided by focal length in meter, but here the values are in centimeter, therefore I change the equation like 100 divided by 100 centimeter means it is equal to 1 meter, okay. Then 25 centimeter, okay, 100 centimeter divided by 25 centimeter plus 100 centimeter divided by 20 centimeter, right. So now this one is equal to 4 plus here this one, that is equal to 5, so the answer is 9, okay. So the actual unit of power, that is diopter, okay. So here the option is, the answer is 9D, D for diopter. So here the right option, that is option 1, 9 diopters. Clear? 9 diopters. So here power means it is equal to 1 by focal length, combination of combination of lens shows a certain power, that is P is equal to P1 plus P2, that means power of the first lens plus power of the second lens, okay. Then I am moving to the next question, question number 6. What is the question number 6? An object is situated anywhere between infinity and optical center of a concave lens. The nature of image formed by it is. See, that means it is very important. Which one is very important? See, the image formation by convex and concave lenses are very important. Okay, so here the question, it is related to the image formation by concave lens. Okay, see, what is concave lens? See, this one is a concave lens. Okay, so now this one is the principal axis. Okay, and now you just consider this one is the focus and this one is the center of curvature in the left hand side, and here the focus and center of curvature is here. Okay, now where is the position of the object? An object is situated anywhere between infinity and optical center, anywhere infinity and between the infinity and optical center. See, which one is the optical center? See, this one is the optical center. And where is infinity? Infinity is present here, beyond C, right? So now you just consider the image is present here. Image is present here. It is surely between infinity and optical center, right? Yeah. Then now the light ray is coming from the object which is parallel to the principal axis. See, we know this one is the path of the light ray after the refraction, right? Yes. Now the another light ray which is moving towards the optical center, it creates a certain angle, create a certain image where in this region. Actually its size is very small when we compare that one with the object, right? Yes. So the image size that is small, image size is small or diminished. See, here there are two options consist the term diminished, right? So see, all other options are wrong because the image is diminished. That is the important thing. And the second one, see, the image is an erect image, right? Erect means it is standing like the object, okay, in the upward direction. It is pointed upward direction. So that one is erect. So here the image is erect. So which option consists image is erect? Yes, this one. So this one, that is the right answer because the image is diminished, image is erect and it is present in the same side of the object, right? Yes, the image is present on the same side of the object. That means the image is a virtual image. If it is present on the other side of the lens, then it is a real image. In the case of real images, that images are inverted in nature, okay, but all the erect images are all the virtual images are erect in nature. Clear? So here the right answer, option B, virtual, erect and diminished. That means it is very well related to the image formation by concave and convex lens. Okay. Then again the next question, question number 7. See, this question, it is related to the refraction of light through a glass prism. Okay, through a glass prism. Okay, see, what is the question? The path of the ray of light coming from air passing through the rectangular glass slab traced by 4 students are shown as A, B, C and D in figure. Which one of them is correct? See, there are 4 figures that are related to the 4 students. One is a student. See, this one is the student's A's image. This one is by B. This one by student C. This one by student, then by student C. D. Okay. See here, which one of them is correct? That is the question. See, here the light is entering to the drier medium to denser medium, right? Why? Because the outer side of this glass prism consists air. When we compare the densities of air and glass, glass is more denser than air, right? So air is the rarer medium and glass is the denser medium. Now the light ray is coming from rarer medium to denser medium. I already discussed about what is the path of the light ray after refraction when it is traveling from rarer medium to denser medium. Yes, it is moving towards the normal, right? So I place the normal here like this. Okay, so there is no angle variation in this case, therefore it is a wrong trace, right? This one is wrong. Okay, then I move to the third one. Second one, please wait, I am explaining the third one first, and fourth one second, and finally I discuss the option number B. Okay, see here option C. See here, I place the normal here. Now there is no angle variation in this situation. Again, this one is a wrong statement, or sorry, a wrong picture. Okay, and I am moving to the fourth option. Now here you place your normal here. Again, there is no deviation in its path. Actually, the deviation present like this, right? So the actual deviation is like this, but here he traced there is no deviation in the case of light when it is traveling from denser medium to rarer medium. Okay, so again this one is a wrong picture. So now I conclude by using this picture. See here, I place the normal here. Now the light ray is coming from the rarer medium to denser medium, therefore the light ray after refraction it moved towards to the normal. Yes, here it is correct. And in second interface, now the light ray is moving from denser medium to rarer medium. Am I right? Yes. So now it is moving away from the normal. Yes, that is correct. So here the right option, that is option B, when the light ray traveling from a rarer medium to denser medium, after refraction the light ray moving towards to the normal, but when it is moving from denser medium to rarer medium, after refraction the light ray surely moving away from the normal. That is the important data which is related to the refraction of light. Clear? Okay, so I am moving to the next question. See the question number 8. An object is placed on the principal axis of a concave lens at a distance of 40 centimeter from it. If the focal length of the lens is also 40 centimeter, find the location of the image. Find the location of the image. That is the question. See here we are using the concave lens. Okay. So you just consider this one is the concave lens. Okay. And the image, where is the position of the object? See, at a distance 40 centimeter. Yes. So you just consider. So I redraw the figure. See, this one is the principal axis, and our object is present here. Actually, it is at a distance from 40 centimeter from the concave lens, right? Yeah. So here this one is the image distance. We represent that one by using the letter U. Now U is equal to minus 40 centimeter. See why it is minus 40 centimeter. See, we measure all the distance from the lens to object or lens to image, right? So here from lens to object, it is we measure the data from right to left, right? We measure the data from right to left. We consider the direction of incident light ray, it is in positive direction. Okay, the incident rays direction, that is positive. Okay, so now we measure all the values from lens or mirror. Therefore here we measure the object distance from lens to object, therefore it is just opposite to the direction of the incident light ray, so it is negative, right? So here it is minus 40 centimeter. Okay, and another data, if the focal length of the lens is also 40 centimeter, that means this object is present where? It is present where? Its focus. Okay, so here the focal length is also minus 40 centimeter. Yeah. Then what is the equation for the lens, or equation related to the lens? See, equation related to the lens, 1 by focal length is equal to 1 pi v minus 1 by u. Okay, so I rearrange this equation to find the value of v. What is v? V is the image distance. Okay, see here our question is find the location of the image. Okay, so how we find out the location of the image? We find out the image distance. Okay, that is the location of the image. So I rearrange this equation like 1 by v is equal to 1 by f plus 1 by u, right? 1 by f plus 1 by u. See here we know the value of focal length and we know the value of image object distance, right? So I substitute that values here. 1 by v is equal to 1 by minus 40 plus 1 by minus 40. Okay, so the answer, that is 2 by minus 40, it is equal to 1 by minus 20, 1 by minus 20. So our question is the location of the image, that means we want the value of the image distance. So v is equal to v corresponding minus 20. Okay, so the answer is minus 20 centimeter. Okay, so in here the option number 1, that is the right answer, it is equal to minus 20 centimeter. See here option 3, that one is minus 1 by 20 centimeter. Actually it is equal to 1 by v, not equal to v. Okay, so the right answer option 1, minus 20 centimeter. Okay, then next question. Question number 9. The angle of incidence is the angle between. Angle of incidence is the angle between. Okay, see the options are the incident ray and the surface of the mirror, the reflected ray and surface of the mirror, the normal to the surface of the incident ray, normal to the surface of the reflected ray. Okay, so you just consider this one is the smooth surface. Actually this question is coming from the reflection. Okay, so you just consider this one is the normal to the plane. Okay, see this one is the incident light ray. Okay, which one? This one is the incident light ray. Okay, see the angle produced between the normal and incident light ray, that one is the angle of incidence. Okay, here our question, the angle of incidence is the angle between incident ray and the normal to the surface. Okay, so here incident ray and the surface of the mirror, that is wrong. Reflected ray and the surface of the mirror, again it is wrong. The normal to the surface and the incident ray, here option 3, that is the right answer. Okay, see the normal to the surface and the reflected ray, it is known as angle of reflection. Okay, not incident ray, sorry, not angle of incidence. Clear? Then our last questions from this chapter, that is, yeah, I already explained this one. F is equal to R divided by 2. F is equal to R divided by 2 is valid for all kind of mirrors. Okay, so here all kind of mirrors means all kind of spherical mirrors. Okay, so here f is equal to r divided by 2 is valid for what are the spherical mirrors? One is concave and another one is convex. Yeah. So here for both concave and convex mirrors, focal length is equal to r divided by 2. What is r? R is the radius of curvature. That means it is surely related to the spherical mirrors. Okay. So for both concave and convex mirror, focal length is equal to r divided by 2. Okay. Thank you very much.